Okay, the 2017 FRQs. Now, this was an interesting year for the exam. They switched things up, and so as we've practiced other FRQs in the past, they've really kind of fallen in one topic area. But what we found this last year is they started to mix the topic areas. So this first question has a table of values given. And now, what usually this means is this is an indication that at some point during the problem you'll be asked to calculate a Riemann sum of some sort. But that really gets you through the first part of the question. Then it pulls out a volume question, as an area and volume, and then it finishes with a related rate. So a lot of diversity in this problem. So we're seeing a trend away from kind of one, maybe two topics in the same question to bringing multiple different topics into the same situation, the same problem. So in this problem, again, we have a table of values. It says a tank has a height of 10 feet. So that's a constant. It says the area of the horizontal cross-section of the tank at height h feet is given by a function, the function a, where a of h is measured in square feet. So this is an area function here. And we have specific area values given in the table. The function a is continuous and decreases. Now I'm just going to put a box around this decreases. If it tells us that, we usually will have to we'll have to use that at some point. And it decreases as h increases. So the area is going down as the height increases as you go up the tank. Part A says use the left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank. So if we're using a left Riemann sum with 3 subintervals, I'll do some kind of background work up at the top on the table. So we're going to split into 3 subintervals. And what that means is I'm going to look at 2 points at a time. So I'm going to have one rectangle that I'm going to look at that goes between 0 and 2, and I'm going to choose the left y value. And that rectangle will have a width of 2 and a height of 50.3. The next rectangle will go between 2 and 5. And for that one, I'll use a height of 14.4. And then finally, the last rectangle will go between 5 and 10, and I'll use 6.5. So that's kind of the background work on this. Now, it says we're approximating the volume of the tank. That's because if we integrate over our area formula from 0, in this case 0 to 10, that's going to give us the volume because we're adding up all of our areas over all of the height values that we can get. So we're approximating that. So the way we write that out in the problem is we would say that the volume is approximately equal, or actually the volume is equal to, I should say, the integral from 0 to 10 of a of h dh. And we're going to approximate that with our Riemann sum. And the approximation for that, we're going to do 2 times that left-hand endpoint, which was 50.3, plus 3 times 14.4, plus 5 times 6.5. And then it is a calculator question, so go ahead and use your calculator. And that volume then estimate, we'll say the volume is approximately equal to 176.3. Now we'll scroll back up to the problem, and you'll notice a piece of this problem says indicate units of measure. When it says indicate units of measure, you're probably going to be getting points for this somewhere. And since it's a volume, we need to have something cubic, and the area was given in square feet. So our unit would be cubic feet. Okay, where do the points come from in this? The points come from using the Riemann sum. So that's going to be this part right here. That's going to be worth a point. And then you're going to get 1 point for your actual answer. And then for the units, here's what I'm going to say. You're going to kind of get a third of a point. You have to have the correct units throughout the entire problem for an extra point. So all the questions that will say indicate units of measure, they all have to be correct for you to get that last point. So we'll say for now that A is worth 2 and a little extra. Now let's take a look at question B. Question B says, does the approximation in part A overestimate or underestimate the volume of the tank? Explain your reasoning. Now this is just a one-point question. What I want you to do for this is I really want you to just always draw a picture, because you don't have to have this memorized. But think of the decreasing function. So if I just draw a decreasing function here, and think about that on a graph, and then think about doing a left Riemann sum. I'm going to actually just draw in my rectangles. And if I take the height at the left side, you will notice that all of these rectangles are above the function. So this is an overestimate, excuse me. And that's all we have to say. And our rationale for it is that it's decreasing. Like I said, that piece was going to come in handy. So to answer question B, all we need to say is that our estimate, or I'll say the approximation, in part A is an overestimate because our function A of h is decreasing. Okay? And that would be a +1 point on the scoring rubric. So those first two parts were all about the Riemann sum. And now it's going to switch over a little bit here. We'll get to question C. It says the area in square feet of the horizontal cross section. So we go right into cross sections. At height, h feet is modeled by the function given by f of h equals 50.3 over e to the 0.2h plus h. This is not a pretty function by any means. But this is an area function. And says cross section. So if I see cross sections, that makes me think of volume by cross section, which is exactly what this problem is getting at. And then it says find the volume of the tank and then indicate units of measure. Based on this model, find the volume. So if you remember correctly, if we do volume by cross section, volume is equal to the integral from A to B of our area function. Well, we don't want to make this too difficult. This is our area function right here. That is our area function. So if we have that, all we have to do is integrate over it. And in this case, our h goes from 0 to 10. So our volume is going to be equal to the integral from 0 to 10 of f of h. And I'm going to use my calculator. It's a calculator question. It's a definite integral. So I've already plugged this in on the calculator and got that in my y equals. Make sure you have the denominator in parentheses. That could cause a problem. And then I'm going to do math 9. Do the integral from 0 to 10 of y1 dx. Calculator will think, and this is my answer. It's 101.325. Remember, we're going out to 3 places after the decimal point. So this is 101.325. Again, we need to have our unit, cubic feet. This question is worth 2 points plus a little bit more for that unit, but you're going to get a point for setting up the integral and a point for the answer. So I would say those 2 points were pretty easy to get. Now, question D. So that was kind of, C was area volume. Now in D, we're going to go to a related rates question. And I'm going to be honest, this one, tricky, very tricky. But you could still do very well on this question, even if you could not figure out what D was asking. It says water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at a rate of 26 feet per minute. So what I know that, since it's giving me a rate of change now for the height, I'm going to say dH dt is equal to 0.26 feet per minute. Using the model from part C, find the rate at which the volume of water is changing with respect to time when the height of the water is 5 feet. So it says find the rate at which the volume is changing. So that means we want dV dt at, or I'll say, not at, I'll say when h equals 5 feet. And that's what's going to make this a related rates question. We're wanting to find a rate at a specific variable value given another rate of change. The question is, what are we using for our volume equation? And what we're using for our volume equation is kind of the setup we use for part C. The volume was equal to this integral of our area function. Now when I write this, because I'm not using the volume to find a specific value, I'm going to put one endpoint as h, and then I'm just going to say f of x dx. And there's a reason I'm doing this. This volume function now written out is going to give me the volume at any h value. Okay, as opposed to what we did in part C, which was find the volume of the entire tank. This is, I'm finding the volume of the water at any h value. So that's why I have this h up here. Now let's think about the process of finding dV dt. Okay, I'm taking the derivative of this volume equation. What happens when I take the derivative of an integral? We have to think about the fundamental theorem of calculus for this. The derivative of an integral, they undo each other. And what I'm going to do is I'm going to take this h and I'm going to plug it in for x. And that gives me f of h. But now here's where it gets really tricky. The h technically is a different variable than our t, and we're taking the derivative of this with respect to t. So I need to do a chain rule, which we sometimes have to do on that second part of the fundamental theorem of calculus, and now I'm going to multiply by dH dt. This becomes my formula for dV dt. So this is my formula that I'm going to now use to figure out what it is when h is equal to 5. So that's the last piece. So I'll figure out dV dt when h is equal to 5. What that's going to be is it's going to be f of 5 times dH dt, which we know is 0.26. And that was given in the problem. How do I get f of 5? I plug 5 into the function in part C. Okay, I'm going to plug 5 into that function. Now I already have that in my calculator, so I'm just going to go back to my calculator. I'll do this the quick way. I'm going to bring up y1, plug in 5, and then I'm going to multiply by 0.26. And this gives me 1.694 as my answer. So it equals 1.694, and then we need to have a unit. And now the unit is how the volume is changing with respect to time. So we're talking cubic feet per minute for the unit. And that's the final answer. This question was worth 3 points. They're going to give 2 points just for that dV dt, and then another point for getting the answer. The units add on a little bit more because we had to have that unit value plus the units in C plus the units in A for the final point. But that is question 1.